I'm Willems, and my thesis was about the truck and container problem, where I helped Van der Bosch, my company where I did my thesis, to make a model which helped them allocate containers to specific routes and choose how to go from A to B given a set of demands, basically. The key takeaways of my thesis were that it was possible to make a model that improved upon the current situation. So currently there were manual planners that do all the analysis and make the routes themselves, and my model was able to allocate the containers themselves, choose routes which were beneficial, and all of this was possible within the mathematical model. And normally within the mathematical model you struggle with the limitations of computation power, for instance, but by choosing to do it with a heuristic, it was possible to actually come up with a solution that planners could validate and see whether it would work in real life, and many of the assumptions made within the model were actually effective in the real life setting, so that was quite surprising. I did not want to use a heuristic that was already available, and that's why I was inspired by the Pac-Man game. And the Pac-Man algorithm itself, it basically takes the container allocation part, so the containers are chosen, and then you have all these yellow dots that you maybe recognize from Pac-Man, and then the Pac-Man algorithm itself has to choose a route which effectively navigates the entire map, but it has to watch out for the ghosts, which are the constraints which make some solutions not feasible. Beginning, you are making a model and you're incrementally building up the complexity of the model itself. You do not know if it will work in the end. After months of working on this model, you finally press the button like run, and then you wait patiently whether it would work or not. Having it working out and it giving output, that was one of the most exciting things about the project itself.